algebra, we are going over PO20, which is finding the slope of a linear function by interpreting a graph or using a formula. Here's the good news. You've done this before. Okay, this is actually on your entrance exam back in September, using this slope formula to, given two ordered pairs, tell me what the slope of that line is. We're also going to look at how to use a coordinate plane as well. So let's just define slope. And we defined it already several times, several different ways on CO19, but it never hurts to write it down again. What does slope describe? What does slope describe? When you hear like the slope of a line is 2/3, what does that tell you about the line? Yeah.
A constant rate of change for y over x.
Constant rate of change of y over x. So slope is change in y. That looks like change ini. Change in y over change in x. And basically what that change in y over change in x tells you is it tells you how a line moves across the coordinate plane. How a line moves across the coordinate plane, both in direction and in steepness. Okay, direction and in steepness. How a line moves across the coordinate plane, both in direction and in steepness. When I talk about direction, I'm talking about going up or down, right? What type of slope has a line that goes like that? Positive or negative slope? Positive, right? Because as you read that graph from left to right, it's going up. So that slope would be positive. How about like this? Going down. Negative. Right? As you read a graph from left to right, which you always should, from left to right, it's going downward. Okay? It also tells us how steep the line is. What would the slope of a line that is very steep be?
Like 9.
Regardless of the sign. What? 9 over 2. Let's go steepness. I mean, let's like 9 over 1, right? Think about that. A change of y of up 9 versus only a run of over 1. We're talking about a slope that's going like this. Up 9 over 1. That's pretty steep, right? That line is very, very steep. What would a not so steep slope be? I'll have to do way over here. Not so steep slope. Yeah. 1 over 2. Let's get even less steep than that. 1 over 1. That's your standard staircase, actually. 1 over 4. 1 over 20. Like if we're going not steep, let's get not steep, right? 1 over 20 would be a change of y of only up 1, and then over 20. I mean, that's what? So not steep. I moved my page over. I mean, that is a very not steep slope at all. Okay? So the relationship of the rise to the run tells you how steep the line is. If your rise is much greater than the run, it's very, very steep. If your rise is much smaller than the run, it's not very steep at all. Okay? So how a line moves across a coordinate plane, both direction, positive, negative, up, down, and then steepness as well. Okay? And then rise over run, how the line moves across the y-axis over x-axis. We talked about all this stuff before. So tell me, given a coordinate plane, how do we calculate the slope? Given a coordinate plane, how do we calculate the slope? What do we look at? Yeah.
You just like count the distance up and then the distance.
You count the boxes. It's beautiful, right? So you find an ordered pair here. You find another ordered pair here. And you kind of just count how you get from one to the other, going vertically and then horizontally. Okay? We're going up 2 over 3. The change in y, we went up the y-axis 2. The change in x, we went across the x-axis 3. So So that slope, y over x, equals 2 over 3. And if we do that slope a second time, up 2 over 3, we're back on the line again, right? It's consistent. Tatum said that earlier. It's consistent change. Up 2 over 3. Second one, what's our slope for that one? James?
Negative 4 over 2.
Not negative 4 over 2.
Negative 2.
Negative 2 over 4. Vertical change always comes first. Okay? Down 2 over 4. Y over x, down 2 over 4. Since slope is a fraction, how should we write this?
2, 1 over 4. Negative a half.
Negative 1 over 2, right? And here's the beauty of it. If we use this slope, negative 1 over 2, and go down 1 over 2, look at that. We're back on the line again. Down 1 over 2, back on the line again. Okay? So that relationship of fraction equivalency shows up here. If you have a slope of negative 2 over 4, it's the same thing as going down 1 over 2 twice. Okay. Questions so far? Again, you had this last year, so light bulbs flickering,
Yes.
shining brightly. Okay? Given two ordered pairs, and this is usually when you'll be finding slope is with two ordered pairs, so this formula is pretty important, thus it's a key point. Yeah, what's the slope formula?
y1 over y2, or y1 minus y2 over x2.
So typically it's written y2 minus y1 over x2 minus x1. However, it doesn't matter the order of these as long as you keep them consistent. Okay, y2 minus y1 over x2 minus x1 will give you the same results as y1 minus y2 over x1 minus x2, right? What you don't want to do would be something like this, y2 minus y1 over x1 minus x2. Don't do that. That would be horrible, okay? But as long as you keep your y's in the numerator and you keep the numbers consistent for how you subtract, you'll get the same result every time, okay? And notice, this 2 it's not a power, right? It's not y squared. A power would be raised. This is lowered. What does it mean when you've got numbers that are resting at the bottom of a base versus the top? At the top, it's a power. At the bottom, it represents what? Order, right? Second y minus first y. Second x minus first x, okay? And where that y2 and y1 comes from is the ordered pairs. This is our first x. This is our first y because they come from the first ordered pair. This is our second x. This is our second y because they come from the second ordered pair. After that, just plug them in, okay? y2 minus y1 over x2 minus x1. Our second y is 10. Our first y is 7. So 10 minus 7. Our second x is 5. Our first x is 3. 5 minus 3. 10 minus 7 is 3. 5 minus 3 is 2. And so our slope is 3 over 2. Okay? Now, what would you get if you flip that around? Right? If you took y1 minus y2 over x1 minus x2, how would that change things here? You'd get negative what? Negative 3 over negative 2.
That just simplifies.
Why is that not a problem?
It just simplifies.
Because a negative divided by a negative gives you a positive anyway. Okay? So the reason why it doesn't matter if you do which formula here, as long as you stay consistent, it's going to work out the same in the end because you should always simplify. A negative 3 over negative 2 simplifies to be positive 3 over positive 2. So either way you do it, it's going to work out the same. Okay? Questions on this? Yes, gladly. Negative signs, you do need to be careful with them. Okay? Let's do, here's our x1, y1, x2, y2, first ordered pair, second ordered pair, x and y. So y2 minus y1, -8 minus 4, x2 minus x1. Be careful here. It's 10 minus -6, right? Because that subtraction sign's part of the formula here. Right? The subtraction sign is part of the formula, and you have an x term that's negative. Both signs need to be included. So it's not just 10 minus 6, it's 10 minus -6, which we know what happens when you subtract a negative number. It changes the operation to addition. So really what we get here, -8 minus 4, -12, 10 minus -6, positive 16, right? This is the same as 10 plus 6 because that minus a negative changes the operation to addition. And then -12/16 simplifies to be -3/4, which is your correct answer. Okay. If you did it the other formula, the second option, you would have gotten positive 12 over -16, which a positive 12 over -16 still gets you -3/4 as the final answer. So it works out the same. You will be able to use a calculator. Just remember that your subtraction sign and your negative symbol are different keys. They're different buttons. So you need to be aware of that. Do the third one on your own just for funsies. Check your answer with a partner before we go over it together. Change in y, change in x. That word change means subtraction, right? That's why it's the operation of subtraction. Change in y. Yes?
What happens if the denominator is 0?
If the denominator is 0, we'll talk about that. That's on the second page. We'll get there after this. In the meantime, you think about what it means. Right? If the denominator is 0, that means there's no x change. There's no x movement. What would that look like on the corner plane? All right, well, you should get y2 minus y1, -5 minus -6. Make sure you have minus -6. Lots of negativity here, but that's just because you've got negative values in the order pairs and subtraction in the formula. And then 14 minus -11 for the x's. What's -5 minus -6? Positive 1. What's 14 minus -11? 25. Is this line steep or not steep? Very much not steep. Okay. Is it going up the corner plane from left to right or down? It's going up. Positive. Up 1 over 20. Very gradually, but it is going up. If you did it the other way, you'd have gotten -1 over -25, which of course simplifies to +1 over +25 anyway. Okay. Success or questions?
Success.
Or both. Maybe you have a successful question.
Can you put an accent button?
Why?
For what?
Just for fun.
No, that must be earned. Earned. Yeah.
Tatum earned it.
Yes, he did. Perhaps someone else could.
Dude, I know this last school.
Geometry got it. I don't remember who
For
though.
what?
Andrea, maybe?
What'd she say?
I don't remember. All right. Second page. Jonas has got a question. This will be your homework. P.S. The rest of this page here, you've got some review questions. We've got brain busters where you go backwards. I give you the slope. You give me 2 ordered pairs that would result with that. So you're kind of working backwards through the formula. But Jonas, which one were you asking about here?
3 over 9 and 3 over 14.
So the second one in the middle row, you do your y2 minus y1, your x2 minus x1, and you get 14 minus 9 is 5, 3 minus 3 is 0. And that should immediately raise some red flags in your mind, because one of those mathematical rules is that you can't divide by 0. Okay? What happens in your calculator if you divide by 0? You get a divide by 0 error. What happens if you ask Siri to divide by 0? Siri tells you that you have no friends, basically. Okay? It can't be done, right? And the reason why it can't be done is because if you think about what division is, it doesn't make any sense. Okay? Division is dividing things into groups, right? You have 12 things. You divide them into 3 groups. There are 4 in each group, right? 12 divided by 3 is 4. You can't have 5 objects and divide them into nothing, because at the very least you have that one group of 5 things. You have something. You can't take something and divide it into nothing. Okay? So I asked Jonas in the meantime here, what is this going to look like on the coordinate plane? When you have a denominator of 0, it means there's no x change, there's no run. What does that look like on the coordinate plane? Vertical line. Okay? And what did we talk about before with a vertical line, or what can you conclude about a vertical line as it relates to being a function? It goes on forever. It's not a function, right? Because all x does is repeat itself. Okay? If you were to put this on a coordinate plane, right? This ordered pair here would be 4, -1, 4, -2, 4, -3, 4, 0, 4, 1, 4, 2. All x does is repeat. Therefore, it's not a function. And what do we say was the connection between slope and functions? Or more specifically, slope and linear functions. They can't exist without the other, right? A linear function has slope. Slope exists because of a linear function. So, my long-winded point to this, when you have a denominator of 0, it's not that slope is 0, it's that slope is undefined. Slope does not exist. There's a difference between a slope of 0 and an undefined slope. A slope of 0 is a horizontal line, right? You drop a marble on the floor, it bounces around, it might roll a bit, but then it comes to a rest. It's not going anywhere because there's no slope. There's no upward, downward. Slope of 0, horizontal line. Undefined slope, slope does not exist. What would the numerator be? If a slope of 0, what would the numerator be? 0. Yep. If there's no vertical change, but you have a run, that's okay. That's just a horizontal line. It's still a function. X does not repeat. But an undefined slope, that's a problem.
The numerator is 0.
There you go. So that one would be on the coordinate plane, it'd be a horizontal line. Slope of 0, that can happen. That's okay. Because in a fraction, 0 can be the numerator, but it cannot be the denominator. Okay. Tricky, but there you go. Homework is the rest of the page. Any other questions on it? Very well. Do tomorrow. That's all I math. Thank you. That's all I want for